Hey guys, in this video, we'll be solving merge to sorted list on LeetCode. This is an easy problem, and if you are someone who already has an idea of what linked lists are, this will be pretty straightforward. Otherwise, I would recommend you to learn about linked lists first, single linked lists, and then come visit this problem. So, just to give a brief idea of what a linked list is, single linked list is. Single linked list is a unidirectional list of nodes. So basically, as you can see it in the image, uh, each node has a value in it, and then it has a pointer to its next node. And in the next node, we'll also have another pointer. This keeps on going as a chain, and finally, the last node will point to nothing. So that's why the last node's next pointer is null. So each and every node, as the function definition it says here, it has a value and a next pointer. So if the value is not defined, if we do not give a list node value, then it's the automatic value is 0. If it has a value, that gets assigned to the list node function. And then similarly, the next also has next will be a node. If it is passed within the list node, it will be present. Otherwise, it's going to point to null. Okay, now the idea is when we are given two linked lists, single linked lists, which are in a sorted, which are sorted lists, meaning the values within these nodes are in a sorted order or ascending order. We need to produce a single linked list combining these two sorted lists. So we need to merge them into a single linked list. So basically merging two single linked lists into another single linked list. Um, Maintaining the order, ascending order. Okay, so let's take the current example, 1, 2, 4, and then null. So I'm representing these L1 and L2, the lists that have been passed into our function in this way. So L1 is basically 1, 2, 4. So that is 1 pointing to 2, pointing to 4, and then the last node pointing to null. Similarly, L2 has 1 pointing to 3, 3 pointing to 4, and 4 pointing to a null. Now, in order to combine these two lists, we need to start off, the approach will be we need to start off with some head, like a dummy head. So we need to have like a node, arbitrary node somewhere. So I'm going to call it a dummy head, and then I'm going to create a node using this function here, and then give it a value of 0. What that means is my dummy head will be 0 and null. Okay. Now what I'll be doing is I'm going to I'm going to retain this value, dummy heads value, but I'm going to use a temporary variable called current node, and then point this to my dummy head because I'm going to build on top of the current node and finally return the dummy head at the very end of the solution. Okay, so now that current node is pointing to dummy head, current node is nothing but the same list here, which with the value 0 and pointing to null. Now so I'm going to have a condition called while L1 and L2, meaning if L1 and L2 are not null, which is the case because they're pointing to the head of L1 and L2 respectively, right? So let me also maintain a pointer here so that we know where the head of the list is. So in a single linked list, the first node is called the head and the last node is called the tail. So we are at this head right now. Okay. While L1 and L2 are not null, which is the case, L1 and L2 are pointing to 1 and 1 respectively. Then we are going to have a further condition called if L1 dot val is less than L2 dot val. So val is the value within the node. And then we are also going to have another else clause. So if L1 dot val is less than L2 dot val, then what we'll do is we're going to use our current node. Okay, current node is 0, right? The current node is pointing to this head. Current node dot next is currently pointing to null, but what we are going to do is we are going to change that reference to L1, right? Because L1 is a smaller value and we are going with ascending order, we are going to do this. Otherwise, we are going to set the pointer to L2, right? That means if L2 is greater uh, if L1 is less than L2, then we are going to show L1. If otherwise, we are going to set the if L1 is greater than L2, we are going to set the current node dot next to L2, which is a smaller value in that case. As and when we are updating current nodes dot next, we also need to make sure that we move our corresponding pointer in the list to the next value. Otherwise, we are always going to stay here at the current value, and then this while is going to go into an infinite loop. That's why whenever I add L1, I know that I need to move to my next pointer. So L1 is equal to L1 dot next. If I'm adding current node, if I'm referencing current node dot next to L2, then I'll be pointing L2 is equal to L2 dot next, which will immediately move here. Okay, so during the first iteration, L1 dot val is less than or L2 dot val, which is false because both are equal. So it's going to come here. So current node dot next will be pointing to L2. So that means I'll be pointing it to L2. So 0, and then I'll be pointing to L2. And then what I'll do is I'll be moving L2 equal to L2 dot next, right? And then it's going to maintain its order of 3, 4, and null. Okay. Now, what I'll be doing is I'm also going to move my current node. Let's call this current node and keep the reference of dummy node as how we have defined in the beginning. So this will still be this. We have copied the dummy node into current node, and then we have modified current node dot next to point to 1, right? So we are going to do it here. So previously it was pointing here, and then we have assigned current node not next to L2. That's how instead of pointing to null, it's now pointing to the entire list of L2. And then we have moved L2 equal to L2 dot next. That's how we have moved our pointer from 1 to 3, right? And now we need to move our current node as well. Current node is equal to current node dot next. Okay, and then what will happen is current node will end up here. Now it's going to continue with the loop. Now what will happen is um, it's going to make another comparison between L1 and L2. If L1.val is less than L2.val, which is the case because L1.val is pointing to 1, L2.val is 3. So my current node dot next, right? So the current node is here, dot next will point to L1. So immediately my current node is going to, the dot next is all of this list. So it's going to be replaced by 1, 2, 4, and null, right? Okay, and then what I'll do is I'll move L1 is equal to L1 dot next. That way I'll be losing this node, and my pointer of L1 will be pointing to node 2 here. Okay, and then I'm going to increment or move my current node to next. Now what I'll be doing is um, I'm going to be moving my I'm going to be comparing L1.val to L2.val. So 2 is less than 3, that is true. So current dot next equal to L1. So it's going to be reassigned, which is already pointing to that particular list. It's going to be reassigned. And then I'm going to be moving my L1 is equal to L1 dot next. So this way our new pointer will be pointing at 4. Okay. Then we are going to move our current node to next. So current node is equal to current node dot next. All right. So what will happen now is um, when we are using 2, okay, we are pointing here, and L1 and L2 comparison will happen as is. So if 4 is less than 3 is false, so it will go to the else case, and current node dot next is will be pointing to the L2 value. So everything after this 2 will be replaced by L2, 3, 4, and null. Okay, then again I'll be moving my current node. So first thing I'll do is L2 is equal to L2 dot next. So this will be moved here. Let me just move it back. Okay. Now I'm going to move my current node is equal to current node dot next. So that means it will end up here at 3. All right. So again, we are going to make a comparison of L1 dot val less than L2 dot val. So L1 dot val is not less than L2 dot val. They are equal. So it will come to the else case. Within the else case, we are going to be assigning current node not next equal to L2, which is all of this. So it's going to be replaced again with the same chain linked list. Now what I'll be doing is L2 is equal to L2 dot next, right? So that means we are at null. Okay. Then this while loop will break because for this while loop to continue, both L1 and L2 should not be null. In this case, L1 is still pointing at 4, but L2 has already hit null. So we are just going to uh, not only do this, but we are going to be moving our current node to current node not next, and then the while loop breaks. Okay. Now we are at 4, right? We have not yet reached at the end of the array on L1. So we are going to have additional checks. If L1 is not equal to null or else, so if L1 is not equal to null, then what we are going to do is current node dot next equal to L1. Otherwise, current node dot next equal to L2. Okay. So what that means is um, after coming out of the loop, it's going to check if L1 is not equal to null, which is the case. It's not equal to null. So we are immediately going to add current node dot next to L1. That means we're going to copy this and replace the current node dot next, which is this, to uh, 4, which points to null. Okay, and then that's the end of our if condition. So once we are done with this, um, we are we have completed all of our processing, and then since current node initially points to dummy node, it's basically a reference. So whatever is being updated here should also be being reflected in the dummy head. Okay, so but dummy head current pointer is still at this place. Okay, so in a single linked list you cannot move the pointer back and then return this. That's why it's very important to maintain a dummy heads copy where the pointer is pointing to the head of the dummy head linked list. Now we just need to return dummy head dot next. The reason why we need to return dummy head dot next is, remember, we have created this temporary node in the beginning here on line 32 when we have used this temporary node to merge the rest of the nodes from these two lists. So we shouldn't consider this as part of our final answer. That's why we are returning dummy head dot next. That means our linked list, the combined or the merged linked list, will be a sorted list of values from the two arrays. Now when you compare it, compare this solution here in the below. This is the expected one on the left hand side. You can verify it with the highlighted part. So it's 1 1 2 3 4 4. So it's 1 1 2 3 4 4 and then pointing to null. Okay, let's go ahead and copy all of our logic here and paste it within the merge to list function, and just skim through it once again. So we have declared a dummy head list with a value 0, and then we have also referenced it to a variable called current node. Now we are going through a while loop, making sure that none of these lists have reached its null pointers. And then basically we are checking the values within each list. If L1 is less than L2, we are assigning current node next to L1 and moving the L1 list to next pointer. Otherwise, we are assigning current node next to L2 and moving the L2 to the next pointer. Irrespective of what is being assigned to current node, we'll always add something to the current node next and then immediately move our current node pointer to its next pointer for the next iteration. And then once anything like L1 or L2 reaches null, then we know that we just need to append the remaining list of either L1 or L2 depending on what is not null. So that is what exactly we are doing here. Since L1 is not null, we are simply putting current node next to L1. and then we just return dummy head, because dummy head's reference will still be pointing to the head. So dummy head dot next, which is the first value in the merged sorted list. I hope this is clear. Let's go ahead and run this solution. Okay, so it looks like there is an error on line 23. That's because we need to initialize new to our list node, because this is a class. So let's run it again. It could not. Okay, what's the current node dot next assignment to a constant variable. Okay, so we need to set this to let, because we are reassigning current node. Couple of mistakes there, but let's see if this is going to pass. Okay, looks like our solution has worked for all the different cases. Okay, if empty lists are there, the output will obviously be empty. If L1 is empty and L2 has 0, the output will be 0. Okay, so looks like it has passed for all the test cases. I'm going to go ahead and submit. So our solution is accepted. So this is how we solve merging of two sorted lists. And it is important to remember this concept of coming up with a dummy node and then trying to stitch the rest of the nodes to this dummy node and finally return dummy head.next. I hope this was helpful and clear. It's been like a longer video for the explanation, but I think it has helped you guys in understanding the concept of merging two sorted linked lists. If you have any questions, feel free to drop them in the comment section. I'll be answering any questions that you guys have. And yeah, if you've learned something from the video, please give it a like and subscribe to my channel. And I'll see you guys in the next videos. Thank you so much for watching.